Welcome to the lesson on circles. In this lesson, we will discuss the basic components of a circle and how we can solve simple problems and then use those principles to solve more complex real-world problems. By definition, a circle is a rounded enclosed figure. Now, a circle is not a polygon because it does not have any flat sides or any angles. So we can take a look at this basic circle. It's important that we notice that every circle has a center and that every point on that circle is the same distance, is equidistant from that center. Now, a circle has two very important lines inside of it. The first line we talk about goes across a circle to the widest point and through the center, and it is called the diameter. The diameter of the circle essentially tells you how wide or how big that circle is. There's an infinite amount of diameters. Now, from that center to the outside of the circle, halfway or half a diameter, we get a circle's radius. These two basic units will help us solve many problems involving circles. But let's think about how practically we deal with circles in everyday life. Imagine that you have a post and you have an animal. It could be a dog, a goat, or a cow, and you tie that animal to that post using a rope. That animal could move around freely, assuming he stays tied to that post, and the space that animal can move around in is a circle. Now, wherever the animal goes, he can only go as far as the rope, so the rope is our radius. The animal essentially makes a circle, and the area that animal can roam around in is the area of the circle the animal makes as it walks around that post still tied by the rope. Now, if I double the radius, I get a diameter. And if I take half a diameter, I get a radius. And it's this interchange that's going to help us solve some problems. Before we solve problems, it's important to talk about the distance around a circle. Even though a circle is not a polygon, it still has a distance around it. It still has a distance of what encloses that space. Instead of using perimeter like we did with polygons, we're going to use the word circumference. Now, circumference is formally defined as the distance around a circle. Now, as early mathematicians studied circles of all different sizes, they noticed that you could take the circumference of any given circle, divide it by its own diameter, and that you would get the same thing over and over and over again, and that same thing is a number that we call pi. It is represented here by this symbol, and as we talk more about pi, again, we know that pi is the ratio of a circle's circumference over a circle's diameter. Now, no matter the circle, if you do its circumference over its diameter, you're going to get this number pi, which we reduce and simplify and accept as 3.14, although this number goes on and into infinity, and it's a number that nobody actually has finalized yet. So from understanding pi and circumference, diameter, and radius, we're able to get two essential formulas. The first formula for circumference involves us multiplying diameter and pi to get circumference, and to get the area of a circle, we take pi and we multiply it by the radius, and that radius is squared. And recall that radius is squared because area deals with square units. Now, working with these formulas and being able to manipulate will help us solve these problems. So let's practice with our first circle, and let's go ahead and find the circumference of this circle. Let's say the radius of this circle is 5. Now, when we look at the circumference formula, I know that circumference equals pi times diameter. I don't have the diameter, but I do have the radius. I do know it's 5. So if I times 5 by 2, I'll get the diameter. So 2 times 5 times pi, circumference equals 10 pi. Now, because pi is such a long and complicated number, many times it is okay to leave answers with that pi. We know what it means. So circumference could be 10 times pi. But if I wanted to go ahead and to multiply 10 by 3.14, I can get a very acceptable answer of 31.4. Now let's work on finding the area of a circle. So I have another circle, and this time the radius is 7. So I got to think about the area formula. Area equals pi radius squared. So instead of radius, I'll plug in 7. So my area equals 7 squared is 49. And again, I get an answer of 49 pi, which could work, but if I go ahead and put 49 pi into a calculator, I get that my area equals 153.86. Again, this number can go on and on forever, but I round it to 2 decimal places. Let's do another find area one, where this time instead, I have the diameter of a circle is 12. So again, the formula for area of a circle uses pi r squared, not the diameter. So I'll plug in pi, and I'll take this 12 and go ahead and divide it by 2 to begin with. Because remember that radius is half a diameter. So the area equals pi 6 squared. Area equals 36 pi. And when I put 36 pi into a calculator, I get an answer of 113.04. Now let's go backwards a little bit and let's work on a problem where we have to find the radius. So let's say I do have the center of the circle. I don't know what the radius is x, but I know that my area is 81 pi. Now can we recall, we know that the area is pi r squared. So if I take that 81 and square root it, I'll get 9. So 9 would have been the radius that would have been plugged into that formula. So by working backwards, I can see that in this case, my radius is 9. And from this, I can take that radius, find the diameter, and find the circumference. Now let's take these basic skills and solve a more complex problem. Let's say that I wanted to find the length around a track, like one we would use for a track and field race. Now, for a track, we know we have some flat sides, and we know that the ends are rounded, and the ends are very close to resembling half circles. So let's say that the track has a width of 50 and a length of 120. So how do I piece together what I know to find the entire distance around of this particular track? Well, let's first multiply 120 by 2, because I do have 2 of the flat sides. That gives me 240. Now, it appears that on the ends, I have 2 half circles with a diameter of 50. So if I have 2 half circles, I can essentially treat this as having one full circle, even though the 2 half circles don't touch. So 50 times pi, in this case, which is the formula for circumference, is going to give me 157. Now if I add these two, 240, the flat sides, and 157 as circumference, I get a total of 397, which will be my total distance around this track. With circles, consider a strong connection to the rotation of objects and agricultural planning within a field.